Hello students, today this will be our fourth class on oxidation number, charge and valency. Up till now we have discussed about oxidation number, charge and valency, and yesterday in my third video I have discussed about some examples which are important in terms of IIT JEE, NEET and other entrance examinations, and equally important they are in your 11th and 12th class board exams too. Yesterday we discussed the oxidation number and the structure of Na2SO4O6, that is sodium thionate, Na2SO4O6, Na2S4O6, sodium thionate. Then we discussed about dimethyl thioketone also, and the third compound was H2S2O7, that is oleum, or H2SO4, concentrate H2SO4 plus SO3. Now our fourth compound today which we are going to discuss about is peroxosulfuric acid. Peroxosulfuric acid. Peroxosulfuric 6 acid. Oxidation number of that acid is 6. There are two types of peroxosulfuric acid. One is peroxomonosulfuric acid, that is H2SO5. Its name is peroxomonosulfuric 6 acid, and second will be H2S2O8, H2S2O8, that is peroxodisulfuric 6 acid. So this is mono and this one is mono and this one is di, O5O8. So peroxomonosulfuric acid is also known as permonosulfuric acid, permonosulfuric acid, permonosulfuric 6 acid. Its another name is Carose acid. And what about the peroxodisulfuric acid? It is also known as perdisulfuric acid. Perdisulfuric acid. See the structure of H2SO5. H2SO5. This is a structure, so we should be good in chemical bonding or in structures, then only we can handle this all. See here, this oxygen is peroxide, so -1. Because of this oxygen, this will be 1 plus. This is -2, so this will be +2. This is also -2, so this will also be +2. Here this oxygen is -1, so this will be +1. So -1, -1, -2, -2 means -6. So sulfur will be 6 plus. Sulfur will be 6 plus. This is exact method. This is exact method. Now we will see the average method. In average method, see here, 2 sulfur, so 2 plus, sulfur 2 hydrogens, so 2 plus, and 1 sulfur, that is to be calculated, and oxygen is 5. 1 oxygen will be having -2, 10 will be having, so will be 0, so X will be +8. But this is not the right way, this is the right answer. Now see peroxodisulfuric acid. In peroxodisulfuric acid, the oxidation state of sulfur is to be calculated. See, first we will draw the structure. S O O O H. Then S is attached with oxygen, that is peroxide linkage. S O H O and O. See how many sulfur are there? 2 sulfur, 2 hydrogens, and 3, 4, 5, 6, 7, 8 oxygens. So H2S2O8. Because of this oxygen, this will be 1 plus, this is minus 1, this is minus 2, this is also minus 2, and this is minus 1. So minus 1, minus 1, minus 2, minus 2. So this sulfur will be 6 plus, and this sulfur will also be like that only, 6 plus. Minus 1, minus 2, minus 2, minus 1. So 6 plus. Fine. So average method, 2 plus 2x minus 16 is equal to 0. So x will be equal to 7. But in actual, it is 6 plus. It is 6 plus. So this is not the right way. But that is average method, and this is the exact method. So for exact method, you should know the structure. You must be good enough in chemical bonding. Then only you can handle such structures. So now in fifth case, Na2S2O3. Na2S2O3. What Na2S2O3 is? Sodium hyposulfite or sodium thiosulfate. It is used in photography. It is hyposolution and used in photography. So now here we will see the structure of this Na2S2O3. NaSSONA, and this sulfur is further attached with 2 more oxygen atoms. So see, because of this sulfur will be, this sulfur will be 0. This is minus 1, minus 2, minus 2. So this sulfur is plus 5. This sulfur is plus 5. Because of this sulfur will be having 0 charge, and this sodium is plus 1, so this will be minus 1. So this sulfur will be minus 1 and this sulfur will be plus 1. Accordingly, you can calculate average oxidation number also. So for that, this structure won't be required. Just only put the values of oxidation number of different elements there in the formula, and then you will get the answer. So this is hyposolution. Now like this, you can take like H2S2O3, you can take Na2S2O3. So H2S2O3 will also be having the same. Now next is H2S3O6. H2S3O6. First we will draw the structure. H2S3O6, that is trithionic acid. Trithionic acid, H2S3O6. Now see, we will draw the structure of this one. S3, this is S3. Now H2S3O6. O6. Now see here, because of this sulfur, because of this sulfur, this will be having 0, and because of this will be having 0. Now this is -2, -2 and -1. So this sulfur will be 5 plus. Like this sulfur will also be 5 plus. What about this sulfur? This sulfur will be, since it is attached with 2 sulfur atoms, and because both of them, it will be having 0 oxidation number. So sulfur here will be having 5 plus and 0 oxidation number there in trithionic acid. In sodium hyposulfite or sodium thiosulfate solution, it is having -1 and +5, and in peroxo monosulfuric acid and in disulfuric acid, peroxo disulfuric acid, in both cases sulfur is 6 plus charged. Now there is one more compound, Fe3O4. 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 In Fe3O4, Fe is 2 plus and 3 plus charged because it is made of 2 oxides, FeO and Fe3, Fe2O3. This Fe is 2 plus charged and this Fe is 3 plus charged. So this Fe3O4 is iron 2, 3 oxide or ferroso-ferric oxide, ferroso-ferric oxide. So this is all about few compounds of sulfur and Fe. So this is all for today. Tomorrow again we will be discussing some more compounds, their oxidation state of different elements. So this is all about for today. Thank you very much.